Hey guys, you're welcome to another video, and in today's video we're going to be taking a look at arrays in Zig. So what are arrays? Arrays are simply a list of similar data types, and when I say similar data types I mean that arrays is a collection of the exact same type. So you cannot have an array contain a string, a boolean, and numbers at the same time. So you can only have an array of strings, for example, or an array of booleans or an array of numbers. You cannot have an array that mixes values like you have in languages like JavaScript and a bunch of others. So in Zig, an array can only contain a specific type. Yeah. So another property or characteristic of an array is that it is of a fixed length, and the length of an array is constant. That means that when you want to create an array, you have to create the array with a constant size. So the size of an array is known at compile time. So those are the very important properties of an array. Of course, some other things that you can do with an array is you can iterate over an array. You can mutate an array if the array is not created as a constant array. And we're going to be looking at all of these things. And you can also concatenate arrays in Zig. We're going to be covering all these things right about now. So let's get started. The first thing we're going to do is we're going to go over how to create an array in Zig. So to do this, we're going to do const, and we're going to call array. We're going to create an array of numbers. So I'm going to show you different ways of doing it in Zig. So one way to do this is we're just going to have these brackets, and then we need to specify the type of the array we want to create, and we'll have to initialize the value using this initializer here. So this way we can specify the values that we want inside of our array. So here you can see I just created an array of 6 elements, right? So that's exactly what I just did. And if you take a look at this, you can see the Zig language server is not always helpful, but yeah, the array we have here is of 6 elements, and one thing we can do, as we've always done, is just print this out. So print out the array, and you're just gonna get 1 to 6. That's pretty much it, right? Sorry, let's run that, and you should get the numbers just as we expect. Now this is one way of creating an array. So once you do this, this is going to create the array, and you can see we have an underscore here to say that we want the size of the array to be dynamic. Okay, and by dynamic I don't mean that this is going to be created at compile time. This is going to be created as soon as you specify the values inside of this initializer block, right? So that's how you create an array in Zig. Now, another way you can create an array with a constant size is I could specify a colon here to say, okay, this is the type of the variable or constant that I'm about to create. And here I'm going to say that this is going to be an array of, say, U8. In this case, I'm going to use U8 as an example. And here inside of these brackets, I can specify the size. So in this case, I'm gonna say 5, and now I can specify the values inside of here. And as you can see, I'm using the same Zig initializer syntax. Before we had this here, and then we specified the type, and then we did all of those things. Another way we can do it is using this initializer syntax, as you can see here. So what you can do with the initializer syntax is do the exact same thing that we've done before, and this is still gonna work. Okay, so let's just run this on the terminal again, and you should get the same result as we got the last time. Now, let's say that you wanted to create an array, but you don't want to specify values for your array. So Zig provides a very easy way to do that, and you can just mark your array as undefined. And this means that the contents of the array is undefined, and so nothing is going to be, it's not going to be initialized basically. So now if you print this out, you should basically just get zeros in debug mode. In release mode, it's just going to be printing out garbage. So yeah, that is how you can create arrays in Zig. Now, the next thing I'd like us to talk about is going to be strings. So what we're gonna do with strings is we could create something like name, and here what we're doing is we're creating an array, right? So if we want to find out, so this is like 1 2 3 4 5 6 7, right? So I could do something like name.len, and the len is a constant, like I said, is a constant for this for an array, is a constant specifying the length of an array, right? So all of this is computed at compile time. So if I try to run this, it should work, and you should see 7 printed here because the size of this array is constant, and you can use .len anywhere you want in the program, right? So one thing we can also do is we can also iterate over an array, right? So let's take a look at that. And if I can, so to iterate over an array, we just use the for loop that we have, and we can do name, and then we just have like a character, and what we can do is std_debug.print, and so this is just going to be a character, if I can format this correctly. And for this, we're going to just put the character here, and then debug.print. Let's put a new line here, and now we can do terminal zig build run, and we got an error. Expected 2 arguments, found 1. Yeah, this one, right? Terminal zig build run, and you can see we print everything out. Now let's just, so we can just see a difference, we can just do this, right? So we see that we're iterating over everything. So you can see that we can iterate over each character inside of this, because like I said, the string is just a byte array, right? It's the byte array with a fixed length. So we can use a for loop like this to iterate over each item inside of this array, and we can do whatever we want with the item in the array, right? So now the next thing we're going to take a look at is going to be modifying values inside of an array. So let's say that we want to loop through this array and we want to specify some values in there, right? So to do this, I'm going to change this. So we're not going to create a const array anymore because we want to start modifying values. So I'm going to say numbers, and this number is going to be of 10 U8, and we're going to specify this as undefined, just like that. And what we can do next is change this to be for numbers, because we want to specify values. We want to get a reference to this, and then what we want to do is we need to change this to number and get the pointer for that. And one thing we also want to do here is use the enhanced for loop in Zig. So what the enhanced for loop lets us do is it lets us specify an array with a fixed length and also an anonymous array here. So the length is going to match the size of what we have here. So it's just a loop that allows us to loop through basically multiple values. So this is going to go from 0 to whatever the size of this array is. And now we need to specify the value in the capture block here. So we're just going to do it as I. And now we're not going to print anything out. What we're going to do instead is we're going to do number, and then we're going to say at int cast I, and we're going to do that. And then, oh goodness, yep. And so the next thing we can do is we just do cd.log.info, and let's just print out the numbers, and any, we don't need the new line here. And now we run this and we're gonna see that we have 0 to 9, right? So if you notice, we start printing from 0, and then so what we did in this for loop, we just looped over the number. We get a reference to it here. We get a reference to the number variable here, so that we can access each element, and we can dereference this pointer. So you can see that we have an asterisk before the capture, and we dereference the pointer here and cast this to an integer. So what this int cast does, you can see, is it converts an integer to another integer while keeping the same numerical value, blah 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 blah, right? So I'm just casting this because I think the size of this is going to be like a u size or something like that. Yeah, this is a u size, right? ZLS is really helpful here. So this is a u size, so we have to cast that to a u8 in this case, and then we just print out the numbers. And so that's how you're going to be able to mutate or modify an array, right? The next thing we're going to be taking a look at is going to be concatenating an array. Like I said, an array is created at compile time, right? You can mutate an array at runtime, which means you can change the values stored inside of the array. Each item in an array can be changed at runtime, but the array itself, right? The array itself can only be created at compile time. So what this lets us do, let me just create two numbers. So let's say we have an array like this, 1 2 3 4 5, right? And we're just going to change this to numbers 1, and then we're gonna create, let's just make everything const, because we don't need to make this mutable. So yeah, const, and then numbers 2, same, u8, 6 7 8 9 10, right? So say we wanted to add these numbers together, right? We want to create an array that contains these two values. Now, one thing we could do to make things really simple is all we just have to do is numbers 1 and 2 is going to be numbers 1 plus plus numbers 2. Very simple, right? So we just concatenate this and this, and we have an array that is the length of this. So if we try to print out the length dot info, and here any again, and array len, and so what we have here now is numbers 1 and 2, and numbers 1 and 2 dot len, because like I said, it's an array. So let's run the project. If we don't have any compiler errors, it should work. So you see here we have our new array being printed, and we have this as 10. So just as we can do this with numbers, we can also do it with strings, because they're just arrays like I told you before, right? So, and then we could do something like const space, and now what we could do here is full name, first name, if I can type, plus plus space plus plus last name. And now let's log this, and this is going to be a string, full name, and printing this, we should see that we get the first name concatenated with a space and concatenated with the last name. So this is how simple concatenation is with Zig. Remember, all of this is done at compile time, right? All of this is done at compile time. String literals are arrays, so you have to remember that. Now, another cool thing you can do, say, I wanted to repeat, I wanted to create an array that repeats my first name, like, 3 times. So repeated 3 times, for example, right? And I'm sorry. Right. So what I could do is do first name, and then we could do something like times 3, right? So what this is going to do is it's going to duplicate the string 3 times, right? And so what we're going to end up with is repeated 3 times, and this, you can see that this has duplicated this here again and again. So these are some really cool things that Zig allows you to do, right? So yeah. So another thing that we already covered, but I just wanted to show you because it's another neat trick in case that's something that you're interested in. So let's go back to our numbers example where we have an array of 10 U8s, right? So say we wanted to initialize our array to, let's say we wanted to initialize our array to 5s, like we want to start this array with all 5s for some reason. So to do that is really simple in Zig. What we can do is use the example we already used, right? So we just do an array of U8, and then, or we could make this simpler and just use this and then multiply that by 10. And what this is going to do is, of course, it's going to give us 10 of these items. So we're not supposed to put 0 here, we're supposed to use 5. And now if I print this, right, you're gonna find that we get absolutely nothing. And the reason we get absolutely nothing is because we're supposed to put any here. And now we should get something 5 for everything. That is really nice, right? That is really, really, really nice. Now, that is some of the coolest things that you can do with arrays in Zig. There are more, of course, with comp time. Let me show you something that you can actually do with comp time in Zig. So say we want to we wanted to multiply, like we wanted to create the array with something like, say, fill it up with even numbers. We want that computation to happen. So one thing we could do with Zig is, instead of just creating the array like this, bear with me, this is gonna be a bit complicated, but yeah, not too complicated, but this is just compile time computation basically. So we're gonna do a block, and then we're going to create that block this way. Let me just put this properly. Cool. And what this is gonna let us do is so we're gonna create var temp numbers, and this is going to be 10 u8 undefined. Right, so we're creating some temporary numbers because, like I said, we wanted to remember what I said. We're creating all of this at compile time, right? All of this is done like before the final artifact is ever generated, right? So what this is going to let us do is we create that, and what we can do now is what I've already shown you before: temp numbers, right? And number. And okay, so we need an index, right? Let's just no, we're just gonna keep, yeah, we need an index, so let's just start from 0. And what we can do with this is we need that pointer to this to make sure that we can modify it. And what we can now do is we can do number this is equal to let's get that index here at int cast and index times index. And so what I want to do is I want to cast this to a u8, but I just want to square this value here, right? I want to square the index. Oh, bless me, right? And what we're gonna get now is, once we're done with the computation, what we're gonna do is we're gonna call break and be okay with the temp numbers. And with this, we should get, oh yeah, so we need to use the result to do something. So let's log this, any, and numbers. And now what we're gonna do is run it to see that we don't have any errors. And you can see that all the indices are squared, right? So here you can see 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25. And so all of this computation is actually done at compile time. Okay, this is done before the program is ever run. And so we're just essentially, all is going to happen in this program is we already have an array that has been populated, and so we're just printing out the numbers here. This is the awesome power that comp time has for Zig. Now we're going to be doing some more stuff relating to comp time. We're going to be looking at comp time in depth in Zig, but yeah, that's essentially everything you need to learn about arrays and some really cool and awesome stuff that Zig has introduced to arrays. And yeah, I will be seeing you guys in another video.
It's 5 o'clock.
Make sure you like and subscribe, and I will see you in the next one. Have a good one.